Hi, and welcome to this video. In today's video, we'll go ahead and understand how exactly we can communicate between two different tasks in FreeRTOS. So, in simple words, we'll go ahead and have a look into the queue-based data exchange and see like what are the different things we have into it, and we'll also see some examples into it. So, let's get into it and then have a look. So, as we start with this, the very first thing before we could start, I want you to know what exactly are these terms so that you can understand as we go further. So let's understand what exactly is task. So task is nothing but some sort of quick little thing. For example, in case of embedded systems and multitasking, tasks are like individual performing basic specific roles or jobs within a system. So in our case, let us say an example that we would take a post office as an example to understand this better. So the task can be a post office with a different workers performing various different tasks. Each worker represents a task in the embedded system. So I hope we are clear with this. Then we have intertask communication. So intertask communication is like communication between the workers to ensure smooth processing of package in the post office. In other words, in case of R, that is in the embedded system, it refers to the exchange of information or data between the tasks to achieve the coordination and synchronization. So this is how the tasks will communicate between each other, or you can say intertask communication is. Then we have a queues. So what exactly is queue? So queue is like a virtual line where tasks can wait to send or receive information. So usually it follows the first in first out principle. So in our analogy, that is in case of our post office example, we can say that like queues are like waiting areas for packages. Each worker has their designated queue where they send or receive package and so on. Then we have something called as sending or receiving the data. So in understanding here, sending data is analogous to the like the way the whole thing is getting processed. That is, you can say it is being sent and so on. Let us take an example of your post office example. So workers send packages by placing them in the appropriate queue, and other workers receive those packages from the queues to process them further. So this is like sending and receiving the data out there. Then we have a blocking and unblocking. So let us understand again back with our analogy. That is, if a worker's queue is full, they have to wait until there is a space available to send their package. So this temporary wait is similar to blocking. And the other way around, unblocking occurs when the queue has a space allowing the workers to proceed with sending the package. And similarly, our thing that is in the task, resuming the execution of a blocked task when it can perform the send or receive operations, that is your unblocking. And blocking is nothing but temporarily pausing the task until it can perform or send some sort of operations or some sort of data out there. So with this thing, I hope we are clear with how exactly the embedded systems can communicate with each other using these queues, similar to the workers in a post office sending and receiving the packages, as we had an example right now to understand this analogy in a better way out there. So by using these different tasks and making sure that we can communicate, we can coordinate, we can send and receive, then we have a block and non-blocking, and then we have a sending and receiving. So this way we can go ahead and perform the inter-task communications. So we just have a look at this thing. So you have some sort of RTOS, that is a real-time operating system task, you have it, and then you have a message queue, and then you have a task again. So something has to be sent from this task that will go into the message queue, and it will get logged into the message queue. The message queue should be large enough that it can consume, or it can say it can hold the number of messages you want to send, and then each of this message will get passed into it. Just in case, let us say that if this queue is full, then if you send something, that will not be sent. It will get blocked and so on, and or it will be like when there is a space available, it will be get unblocked, and then that message will get sent out there. So that way the whole data, or you can say that data, will be passed from one task to another task out there. All right, so I think so now we have a good enough idea like what exactly happens into the RTOS, task or inter-task communication. So from one task, that the message goes to the message queue. Message queue is like a buffer place where it can hold the messages which has to be transmitted or transferred to the other task, and then the other task will receive that. So let us create one simple quick program out there where we'll have two tasks. So one task will send a message turn on light, and then the other task will receive that and then do accordingly. Again, after some time, one task will send turn off light, and then other one will receive that and do it accordingly. So let's proceed with the program out there and have a look into it. All right, so here we go. Here I have a quick example with me wherein we can proceed with. So in this, we have a two little task. One is a producer task. I have one is a consumer task. I have it, and then there is something which producer task does. Then so there are a few things which producer task does, and then there are a few things which the consumer task does. Okay. So let me just give you an overview into like what exactly each line here does it, so that you have at least a understanding what is happening. So in the first here, what I'm just doing is I'm just defining a constant name LED pin with the value 2 representing the pin number for the LED, that is inbuilt pin for ESP32. Then we are going ahead and then declaring a variable Q of type Q handle. So this is the one which is going to hold the reference to the created Q. And we have also assigned an integer variable, that is Q size, with the value of 10, indicating that the maximum capacity of the Q out there. So I think so earlier, like I just had given you a quick understanding here. If you just have a look at the Q here, so here the Q capacity is approximately 6, right? In our case, it's going to be of 10 here, because that's what I have mentioned here, 10 of that. And then we have few lines of setup here, wherein I'm starting the serial communication out there at 11.9600 out there, and then we have a LED pin made as an output out there. And then what I'm just doing is I'm creating a Q equals to xQ create. So this creates a queue with a specified size and item size. The queue is assigned to the, and then the queue is assigned to the queue variable out there. And then we have the queue creation fails, like just in case if it fails out there, then we'll go ahead and write the error creating the queue out there. And then what I'm just doing is I'm using the X task create to create two different tasks known as a producer task, and one more is a consumer task. And both have the stack size of 10,000 words I have there. And then a priority of 1 is being given to it, and the tasks are created without specifying any task handle out there. Now we have a loop here. So in this loop, it's going to help me continuously execute after the setup function. And in this case, it's a like within every 1 second delay we are doing it, that is with the help of a V task delay, so that before we could repeat the loop, there is at least a 1 second delay here. Then we have a first task with us, that is my producer task, right? So producer task has been defined here, right? So now I have a producer task here. So the producer task is the function that sends a message to the queue, and then that queue will then send the message to the RTOS. So in another example, let us say like this first RTOS task, what you see here, the one which is the first one here is nothing but my producer task in our case. So in this, I'm creating an array of message, and it has a two strings. One is turn on and one off. And then I have a message count, which is going to calculate the number of elements in the message array. So, and then we have a loop here, that is a for loop I have used to send a message to the queue. And the loop runs for the queue size iteration. So what is the queue size we have given there on the top? That was 10 out there. So 10 times is going to run it. And then message is sent in a selected from the message, that is we are going ahead and then sending the message every 1000 milliseconds, that is going to 1000 seconds. And then we have something called as a queue send, right? So sorry, we have a queue send. So this is going to send the message to the queue with a port max delay as a maximum blocking time. And we have a V task delay, and then in the V task delay we are introducing the 1 second delay between the each message which is being sent out there. And then once this loop is completed, that is this int I and then I less than the queue size, that is 10, and then once this is completed, then I'm deleting this task, V task delete null. This deletes the task when this loop gets finished. So I'll tell you one more thing, like interesting, what happens when this V task delete happens. I'll show that to you in the output. Then we have a consumer task, that is another task out there, and the same thing happens here. So what is happening here is now this is the one which is going to receive the information or receive and process the message from the queue, because the producer task is sending it to the queue and the consumer task is going to receive that. And received message as a character pointer used to store the received message here. And then again I have a loop here, and then it blocks again. We have a queue xq receive, and this again going to use the port max delay as a maximum blocking time. And if the message received which has been received is turned on, then I'm making the LED pin to high and printing serial LED turned on. And if it is a received message turn off, then I'm turning it off out there, and again I'm deleting the task out here. So now this is what is happening here. Let us understand with the example like we were having in our presentation out here. So this is my producer task. The first one what I have is my producer task, and this producer task is going to send a message that is turn on and turn off to this message queue. And then this is the consumer task. What in our case it was, what was it? It was a consumer task. So it is going to receive that message from the queue and then perform accordingly. So one more thing was like this is going to do it for 10 times, okay, 10 times itself, and the message queue was set, capacity of this was also set for 10 times. So 10 times, this capacity was also 10 times. So after 10 times it is being done with a loop, it is going to kill itself. That is, it is going to go ahead and then delete this task. Similarly, this is also after doing the 10 times, it is going to delete the task. Every single time it happens, it will receive, it will do the performance, it will do accordingly and then kill itself. That's what is happening here with this two tasks. So now let us see it into working, like what happens. I'll just go ahead and upload the program out there and then have a look. So my ESP32 is connected now to the COM4 out here, and I hope we are good to go ahead with this. So I have my quick ESP32 out there with me here, where ESP32 with me out there, and then we can proceed now here to upload the code. So I'll go ahead and click on tools out here, and then I'll upload this code and see what really happens with this. So we'll just wait for the code to get uploaded and then see what happens. The code is getting uploaded here, and somewhere it says that it was opening the scale monitor out there, but I think so the message, the thing got uploaded by the way. So let me just open the CL monitor and have a look into like what's really happening in the CL monitor and what is the message I'm getting. So I'll just close this, open a CL monitor and have a look at that. Because I can see this light blinking, okay? So just wait a minute. So if you just have a look at this, you see this, like I'm currently not getting anything out here. So what I'll just do is I'm going to restart this and open this again. Most probably be getting some sort of, okay, I think so that I have to set this to 9600 out here because the baud rate was set to 9600. You can see LED turned off and then it turned it off here. So like even this got stopped blinking. Let me turn it on again here. Then it turned on, turned off, turned on, turned off 4 times, 5 times, 6 times, 7 times, 8 times, 10 times, and then this got off. So this is not working after 10 times it's been done, and you can also see this like it only printed for the max of 10 times. The reason this is happening is we have done one quick little thing. What was that? The thing what we had done was we had went ahead and then given one little thing, and what was it? That is delete the task once the iteration has been completed. So when this is done, it's going to kill itself, like delete the task. So whenever the task has been deleted, the ESP32 will get restarted. And that's the thing, it it just gets off. So we are just making it null and then stops and it goes off. No more tasks available. So this is a quick example into how can you do it. But now that's not enough for us. Let's proceed a little bit further and then take one more example into it, which is a little bit advanced. And we'll try to see like how exactly this thing happens to be and what are the different aspects of the things we can proceed have a look into. Okay, if we just have a look at this example here. Now in this, what I'm just doing is I have a quick little thing, but before this let me explain you like what is the thing I have here so that you get to understand this thing. What's happening in this example is that I'm going to make it a little bit more complicated and then show it to you like how it happens to be. So I have 4 tasks here. So I have one time task, one is a hall read task which is going to read the inbuilt hall sensor values from the ESP32, and one more is Wi-Fi task which is going to handle my Wi-Fi connectivity and reconnectivity, and then there is a queue and then there is a printing task. So time task is going to fetch the real time from the internet, and then hall read is going to read the hall sensor value, and Wi-Fi task is going to handle the Wi-Fi connectivity, and they all are going to like send it to the queue, and the printing task is receiving the data from the queue, and then printing task will go ahead and print me in the serial monitor the time stamp plus the whole read value going to print it. I think so we have not included this thing, that is Wi-Fi task, but yeah, Wi-Fi task is going to handle the Wi-Fi connectivity. So this is what is happening into our code now. Let's get back here into the code and then understand this thing. I'll just make it a little bit faster here, not go much deeper into it. So I'm just including one time library here, and then same number, same pin, and I have a queue handle that is whole queue and a time queue, and then I have a queue size set to 100. Okay, the capacity 100. Then I'm using task handles, four different task handles. There is my Wi-Fi name and Wi-Fi password. There is the NTP server for getting the exact time, and then this is the GMT offset for getting the plus 5:30, that is IST Indian time out there, and then the daylight offset is set. And here I'm quickly initializing the 115200, that is going ahead and then getting the serial monitor being started, and then pin as an output here, and then I'm just whole queue and time queue, I'm setting it to int and string size of queue size, and then whole queue and null and time queue is null. Then I'm selling that issue with creating the queue, and then I'm just creating all the extras, create pin to core. So I'm just using pin to core so that I can just put them into specific cores. So just have a look at this, like this task is set to 0 core, 1 core, 0 core. We have two cores in ESP32, right? So one is for the 0th core, one is for the first core, and so on. It's been into core number 0, core number 1, core number 1, core number 0. Then again here just looping in every 1 second, and then I have a whole sensor task. What is it doing? It is always while, that is always active. So what is it doing? It's just reading the whole sensor value and then storing the whole value and then sending it, that is port maximally, and then queue send, it sends to the queue every 500 milliseconds. Then we have print task, that is second task we have. That what is it doing? It is just receiving the data from received whole value from the queue, and then string receive time. So it is, this receive time is coming from the one more task. Let me come back to it. So let me go to the task time. Task time here. So in the task time, what I'm just doing, I'm just setting the GMT offset, daylight offset, NTP server, time info, and then getting the time info here with the minutes and then seconds and then hours. And then if it is not happening, then obtain time and retrying it. And I'm not killing the tasks out there. You can see I'm not killing, I'm not putting in the loop, anything such. Now I want them to active. Now this time task is sending a time to the queue, and the whole sensor was sending a whole value to the queue. Now the print data task is receiving both the things, that is received whole time value and the received time. Received whole value and received time. This is coming from the this one, that is whole sensor task, who is sending it to queue, and then this is receiving that. Similarly, receive time from the time task, which is being sent to the queue and then coming back to the receive time. I'm just getting both of them here with some sort of timeout delay, maximum timeout here, and then I'm printing the serial timestamp receive time and whole value in the serial monitor. And then Wi-Fi task is just making sure that it is always connected and then connecting to the Wi-Fi. Once it has been connected to the Wi-Fi, I'm killing this task out there. Okay, so this is what is happening. So pretty much good example we have it with this. So in other words, if I just have to come back again to the presentation here, so time task is going to send the time value, whole read task is sending the whole read value, printing task is consuming both of the data coming from this, it is stored in the queue and then printing that here. And I'm not using here the kill task or any loops here. Okay, I'm not using any kill task or any loops here in this what we say in the printing value here. I could have given if I equals to less than the way we had given in the previous example, that is less than 10, and once the 10 is being done, I can have deleted that, but I'm not using that thing here. So let's get into it. Let's upload the code here and then have a look what happens. Now we go with this thing, and I'm uploading the code here. Let me just wait for this to get uploaded. So it's getting uploaded now here, so let me just wait for it to get uploaded out there, and then we are good to go with this. So it's done here, and if you just have a look at this, it's done. And let me open my serial monitor out there, and it's let me get the output, and it's 115200. I'll change this to 115200, and yeah, let me restart this and see what's happening from the starting. So connecting to the Wi-Fi, connected to the Wi-Fi, and then it starts to go ahead, fail to obtain time. Okay, retrying it again, fine. And then let me just wait for it to get time. Okay, it is failing. Earlier it was getting the time, but it's some reason it's not getting the time. Let me restart it again. Okay, it got the time. The 1237 is the correct time and the whole values are there. So this is just the whole value coming from the inside and it is printing it. Fine. And it's going to keep doing this thing constantly, and like how is this getting it? This is coming from the two different tasks, two different values, and then one task is printing this. And the connectivity was being done with the one more task. So this is how you can make use of your intertask communication in FreeRTOS and create different tasks out there and then send the data between them with the help of queue and set the queue sizes, timeouts sizes, and all of these things to handle the things better. So I hope this gets you a very good understanding into like how can you go ahead and implement this thing into various different tasks, and they are really a good thing to implement in your projects. So if you have learned something with this and you found this video useful, then do subscribe to the channel and then hit a notification icon out there and share it with the others and keep learning. And do comment in the section below so that I get to know like what next thing you want me to go ahead and try out. So until next time, take care.